So what would you mean by 12.25?
So they're referring to the 12.25 at the start of it.
Yeah.
Uh, let's see. A spear is thrown. So the meaning of 12.25. So in terms of pure maths, that would be like the y-intercept or something.
Yeah.
In terms of this one, this is an equation that models the flight path of a spear being thrown. So it would be something like that. So they throw the spear, it goes up, goes down. In terms of pure maths, I should have done it up a bit. So in terms of pure maths, you would say like x and y, that's the y-intercept. This time it's time and height. Any idea about that?
No.
I think that's the starting height. It's when time is 0, so it's the initial height of the spear.
Yeah.
And it's a very common question. Okay, any idea how to do B?
Would you have to work out the equation first?
And how would you do
that? Would you put it into the calculator as a polynomial?
Correct.
Okay.
And that's because it's when height is 0.
Yeah.
When it hits the ground, the height is 0.
So x1 would be 3 plus square root of 19 over 2. And x2. Pardon?
Let's do it as to a decimal or something.
To a decimal, okay.
And you can...
Oh, it's x1 is 3.6792 decimal places.
Let's say 68, something like that. Okay.
Okay. And then x2 is minus 0.68.
Okay, and so which is it? After how many seconds does the spear hit the ground?
Would it be h1 because it can't go negative?
Correct. It's my mistake. Should be t1, sorry.
Okay.
Yeah, so it's when the height goes to 0. And so in terms of pure maths, you can see the negative one would be to the left side.
Yeah.
But in this case, it's a real world thing. Question C.
So would A, B, and C, would A be minus 4.9 t squared, and B would be...
No. Do you recognize this format?
Yeah, I do.
So this is completed square form.
Yeah.
And you'd have to put it into completed square form. Let's see. So when you put this into your calculator, see if you can get the maximum for it.
Okay. The maximum is 1.5.
So the time is 1.5. So that's going to be the t 1.5. T minus 1.5. Okay. And what's the maximum y?
Let me check. 23.275.
That's 23.275 minus, and we have to factorize. What would you have to factorize out from the bracket? So if we were going to complete the square for this one manually, how would you go about it?
Would you factorize minus 4.9?
Yes.
Squared.
And so I believe that one's on the outside. So that's hopefully a quicker way of going about it. And question D.
I don't know.
Yes, you do. What's the maximum height? What time does it reach that maximum height?
Let me check. 1.2.
You said it was 1.5 a second ago.
Oh yeah, 1.5. Sorry, yeah.
So 1.5 seconds, and what height does it reach?
3.68 meters.
A second ago, you said it was 23.
Oh, 23. Is it 23?
Yeah.
23.275.
Yeah. And so let's see. So that's 23.275, 1.5. And yeah, so I used those in the calculator. So that was the maximum for X.
Yep.
That was the maximum for Y.
Yeah.
Or, well, that was the maximum X at, like, that was the X at the maximum Y. And then we had to factorize out the minus 4.9. So you could do it manually, but it's just quicker to do it this way. So we were doing quadratics. This is now like real world quadratic, or basically you can model the flight path of the spear as a quadratic curve, and so you can use all of the stuff you know about quadratics. Very common one is when time is 0. That's the initial height or the initial y in general. Yeah. So that is when x is 0. Question B is when y is 0. When does it hit the ground?
Yeah.
Any questions about that?
Nope.
So you're just applying the stuff you previously learned. So let's see this one. Okay. Okay, let's try this. Question A.
Okay. So is it when it's 200, the cable's at 0 in meters?
Yes. So interpret means in the context of the question. What's the practical interpretation of that 200?
So when the height of the cables is at 200, displacement is at 0?
Something like that. Yeah. So when x is 0, the height of the cables is 200.
Yeah.
And so the cables are 200 meters above sea level. Yes. Okay. Height equals 200 meters. Let me see something for a second. Okay, let's try this. Hang on. I'm doing it. trying to do similar ones. Let's see. So this looks kind of similar.
Yeah.
Okay, how about this one?
So we're doing question A first, right?
Mm-hmm.
So would it just be minus x equals minus 0.04x squared?
The horizontal distance traveled by the ball. What did you say, sorry?
X minus 0.04x squared.
Yeah.
So is that the answer?
No. They want this distance, horizontal distance.
Okay.
Any idea how you do that?
Don't know.
You could put this into your calculator and get the roots.
As a polynomial, right?
Yep.
So what would x and the plus number be?
0 if there's no
0.
constant.
So I got x equals 0.
Mm-hmm. Is there an x2?
No.
Pretty sure there has to be.
Let me check.
So minus 0.04 comes first, because that's the x squared one.
Yeah.
Then 1, then 0.
Oh, you keep it as 1. I didn't know that.
Yes, it's not 0, it's 1.
Okay. Minus 1, 0. Yeah, so x1 is 25 and x2 is 0.
And so, any idea what the horizontal distance is?
25.
Yes, because it starts from 0.
Yeah.
Okay. Part B.
Okay. So would 25 be one of the constants? Well, that part of the equation.
No. Does this format? What format is this?
Is that complete the square?
Mm-hmm.
Oh, so would A be minus 0.04?
Mm-hmm.
So it'd be minus 0.04 x minus And b would be 1 still, right?
No.
Not minus 0.04.
No. Use the maximum. Put it into your calculator.
12.5 minus 12.5. And then squared. And then plus 12.5 squared.
Is that what the calculator says?
6.25 for y.
6.25. So you could do it manually. But yeah, when x is 12.5, this first thing is the square bracket is 0, which is what you need to make. And so the y is 6.25.
Yeah.
Question C.
So would the maximum height the ball reaches be 12.5?
That is the time, 12.5 seconds. That's the x. In this case, x is time. No, sorry, x is horizontal distance. Yeah, the horizontal distance. When distance is that. So that's the horizontal distance when it reaches its maximum.
So would the height be 6.25?
Correct. So the maximum height is 6.25 meters.
Yeah.
That's it. When distance. Let's see. So yeah, you use the roots to show that there is 25. It starts from 0, and so the horizontal distance that this ball travels is 25 meters. You know, it starts on the ground, stops back on the ground.
Yeah.
Write it in completed square form. So you can do complete in the square. You can do it the long way, or you can use the calculator. The maximum x goes in the bracket with the x. The maximum y goes outside the bracket, and then just use those for question C.
Yeah.
Any questions about that?
No.
Okay. There we go. 1.5. Okay, how about this one?
Okay. Would we find out the two roots first?
Okay.
So it'd be minus 5.25 x squared and then 73.5x plus minus 107.5. So x1. So how many decimal places?
Money.
2 decimal places. 12.34. And x2 is 1.66.
Okay.
So it's in thousands of pounds as well.
So you'd have to. So you could say. I would try to put it. So you might have to times those by 1,000 then.
Yeah.
Or something like that.
Now.
Yeah.
Okay.
You could say 12.6 thousand, or maybe that's fine.
Yeah.
Okay, it's 12.6 thousand. 12.6k. I think that's what they say.
Okay. So
And so what was A? What was B?
A was minus 5.25. A equals B is
Okay. I mean, in the like, what's the answer to the question?
like the roots.
Yeah. Was it 12.3 and 1.659?
Yeah, 12.34, 1.66.
Okay. What do we do with those?
Should we just do we times them as by 1,000 and keep them as they are right now?
We'll just keep them.
Okay. Do we put them into the completing a square equation?
How would you put them in?
Would x1 go into A?
The completed square form shows you the maximum or minimum, and so it's not the roots that go in. It's the
maximum and minimum.
Yeah.
Okay. So the maximum is 7.
Right.
Max 7. The minimum. No, the maximum of y as well. Is 149.75.
Okay.
So then do we put is the A max 7?
The maximum x, the x of the maximum is 7, and so that goes in the bracket with the x.
Oh, okay. So 149, would that goes A? Oh no.
Yep.
0.75.
That's the y.
So it'd be 149.75 minus 5.25 brackets x minus 7 close brackets squared.
That's it. And B.
So the maximum possible annual profit is 7,000.
The profit is the
Oh, so it's 149,000.
yeah, 149.75 thousand. That's the maximum possible profit.
Yeah. The selling price of the phone case that maximizes it, would that be 7,000?
Yes. I believe that one's just 7.
Oh, just 7.
And
okay.
it's the other one that's in thousands. And next selling price measured in pounds. Yes. Let's see. There we go. And so we didn't need the roots for this one.
Yeah.
So you can see here, they did it the old-fashioned way. You factorize out minus 5.25. Then you've got x squared minus 14x, and they changed that into x minus 7 squared minus 7 squared.
Yeah.
And they end up with these numbers. But if you can use the calculator to just get them, that's helpful.
Okay.
Any questions with that?
Nope.
Okay, how about this?
Okay. So the coordinates of point A would be 2.5 comma minus 3.
2.5 will be down here.
Oh, so it'd be 1.25.
Yes. Very good. Part 2.
So would those two numbers be used in the equation?
Yeah, how do you use them?
So would 1.5 be A? 1.25?
Like what? 1.25 x squared, is
As
it?
in A and then x squared plus bx plus c. Or would that be wrong?
No, that's wrong. This is the minimum point. When do you get a minimum?
Is that incompleting square?
Yeah.
So you put it into incompleting square.
Yeah. And you know what format completed square form would take in general?
Yeah, it's the number on the outside and then bracket x plus a number, close bracket squared, minus or plus a number.
That's it. I call to them A, B, and C, but I'll call them D, E, and F. So
Yeah.
I think A is the same, but okay. So what is what?
So the minimum is -3. So would that be E or D?
-3 is the Y.
So that would be F.
Correct.
And 1.25 would be E.
Correct. X plus 1.25. So now we just need D. How could you get D?
Could you work it out? Work it out first.
How would you do that?
So would you?
Easiest way would be to sub in a coordinate.
So just sub in 1.25 and then comma -3. Would that be a coordinate?
Actually, hang on. This should be, I believe, -1.25. It's always the other way around.
Okay.
Minus 1.25 for that, so that bracket becomes 0. That will end up giving us 0. If we put in x is 1.25, then we'll get 0. So that will eliminate the d. So that won't work. Any other coordinate we can use?
2.5.
Yeah, we can use that one.
And then comma -3. Or would it just be 2.5?
So what is the coordinates of the 2.5 point?
Oh, 2.5 comma 0.
Yes. So that's what you can sub in. X is 2.5, y is 0. So 0 equals d. 2.5 minus 1.25. And you can solve that in a calculator. Make your life a bit easier.
Okay.
And I have to use x instead of d. Do you remember how to solve it? Using the calculator?
So it'd be 0 equals x, because I don't know what d is.
Yeah.
And then open brackets 2.5 minus 1.25 close brackets squared minus 3. And then, is it shift and solve, right?
Yeah, shift calc for solve. And then just
then what? Pick a random number.
Yeah.
So I got x equals 1.92.
I got the same. X equals 1.92. And so, what's the final answer for this question?
1.92.
Equation for the curve.
Oh, so it'd be 1.92. 0 equals. We should put 0 first.
Y equals.
0 equals. Y equals, yeah. 1.92 open brackets 2.5 minus 1.25.
No.
X.
Yes.
X minus 1.25. Close brackets squared minus 3.
That's it. Y equals 1.92 x minus 1.5 minus 3.
Yeah.
Okay. What was this part B down the bottom? So this is a cross section of a canal.
Yeah. What does it mean by a narrow boat?
Just a boat.
Just a boat. Well, it's only 2.5 meters across.
Okay.
So I don't think a boat will be able to cross through there.
Only 2.5 meters wide.
And only 3 meters deep.
So no.
Yeah.
It's like 0.2 meters too big or something. The boat is...
Yeah.
Boat is 0.2 meters too big. Too wide. The canal size is 2.5 wide, so the boat is too wide. Yeah, great.
Yeah.
And so, yes, when you use your... So completed square form shows you the minimum or maximum point. The sign of the x is always the other way around. And so that goes in the bracket with the x, the y goes on the outside. And so you can use that to get the equation of the curve. Any questions there?
No.
Let's see. Let's see this one. A model to determine. Okay, let's see. Yeah, okay, how about question 1?
Okay. Well, the models don't contain a constant term because W affects the number of cars produced per day, so it can't be constant.
They're talking about a constant like +3 or something like that.
Pardon? What did you say?
So a constant is a number. So like here we had a little extra like minus 3. And so why is there no constant like +7 or something? Like a number without a W?
Because the number of cars is always changing.
No, that's not what they mean by constant. It's not the opposite of variable. Well, it means a number. It's because 0 workers make 0 cars, essentially. This would go through the origin 00.
Oh yeah.
It's not like if no workers come to work, then 7 cars get made.
Yeah.
Constantly. It's not like if you don't use any electricity, or let's say you don't use your phone, you still get charged like £5 a month as such, some kind of constant charge. Okay, question B.
So would it be 0.4 times 1,500?
Yep.
Which would be 0.4. 600.
Okay.
And then you do 0.00008 times 1,500 squared.
Mm-hmm.
No point. Wait, so would you square it first, or would you do brackets first, right? So it'd be 0.00008 times 1,500.
You would just put it into your calculator as it is.
Okay.
1, 2, 3, 4, 8. So I always write it down the way you can put it in the calculator.
180.
Yep.
So it'd be 600 minus 180, which would be 420.
That's 420 cars. 1,500 workers make 420 cars. Question C.
So now would you put it into the calculator
to
find out the maximum? So it'd be minus 0.1234 and then 8 and then 0.4 and then kept to 0. So the maximum would be 2,500 cars.
And they wanted the number of workers that are needed to make that many.
Would that just be X1, which would be 5,000?
Yes. 500 cars. 5,000 workers. Let's take a look. 500 workers, was it?
We said 5,000, unless I got it, put it in the calculator wrong.
I think something's gone wrong. So minus 0.00008, 0.4, and 0. So I'm getting 5,000. Then, oh no, max of X 2,000. I think you gave the root. Just press it again.
Oh, yeah, it's Y, so it's 500.
And so, go on. What is the answer then for this one?
So would the amount of cars produced be 500?
So 500 cars, and how many workers are needed to make that many?
2,500. Is that right?
Let me just check. So 2,500 workers and to make 500 cars. Yes, because the X was workers, and so that was the maximum X, and the cars is the Y, and so
Yeah.
Great. Any questions there?
No.
Okay, so I think you have the idea for the maximum stuff. There we go. 0 workers produce 0 cars. Great. Let me see. All right, let's try this one.
Is 120 the height of the ball of where it's at?
The height of the ball when
it's not thrown yet. When it's
yes.
So
that's like the starting height, something like that.
Yeah.
Okay, B.
So would B be minus 4.9 as A?
Yeah, is this the same question? This is 120. Is it just a very similar number? I thought I saw minus 4.9 somewhere. Yeah, so it's similar, but it's not the same. Okay. Yeah, sorry, go on.
Right. So it'd be minus 4.9 minus would B be 12.25?
Yep.
So it'd be minus 12.25 brackets T minus 120 squared.
Sorry, I didn't realize you were talking about capital.
Oh, we need the roots first, don't we?
So you have to put it into calculator.
Okay. So it'd be minus 4.9 and then 12.25 and then 120, which would be x1 is 6.35 to 2 decimal places, and x2 is minus 3.85 to 2 decimal places. And the maximum of x 1.25. The maximum of y is 127.66 2 decimal places.
Okay.
Yeah.
Okay. What do we do there?
So do we use both maximums and put them into the complete the square form?
Yep.
So would C be the maximum of y?
This C, is it?
Yeah.
That's in the bracket next to the T.
So do the maximum of x.
Yep.
So B would be the maximum of y.
No.
So it'd be T minus 127.66, right?
No.
So it'd be is C the maximum of x or y?
You asked me that twice already. Maximum, it's in the bracket next to the T. You already said so. It's the maximum of x.
So it'd be 1.25.
Yes.
And would A be minus 4.9?
No.
Well, minus B then.
Yes. So this is the 4.9.
So then Y is A.
Yeah. So what is A?
Minus, no, 127.66.
Yeah, I was going to say 128.
Yeah.
Yes. It's a bit confusing that they say A, B, and C. I wish they'd say D,
Yeah.
D, E, and F or something. Because here, like, little a, little b, little c are these numbers up here. Okay. Okay. Question C, part 1.
Would that be 1.25 seconds?
No. So if we were to graph this, it would look something like that. So this is the time. Is that right? Yeah. So this is the time, this is the height. And so you have to say, so what time is this here when it hits the ground? What time does it hit the ground at? How do you find that?
Would you work it out?
And how would you work it out?
Would you make it equal to 0 first?
Yep.
So would it be 0 equals 127.66?
No.
Minus.
This is when the h of t is 0. So it's like 0 equals ax squared plus bx plus c. And that's the one you solve. And I believe you already got the roots.
So would it be the y root? Oh no, x2.
Yep.
Oh no, it's x1. Would that be 6.3?
That's it. So that's like 6.35 seconds, is it?
Yeah.
Yes, 6.35 seconds. And so, yeah, that one is 6.35 seconds. And so this is like 0 seconds. It's thrown. When does it hit the ground? It's when the height is 0. When the height is 0, you know, that's, 6.35 seconds. And question 2. C, part 2.
Would that be 1.25?
So which is which? What are the units? What is time? What is
Oh no, it'd be
height?
127.
Sounds good. 120.
666. 128 then.
Yeah. And what's the unit for that one?
Is that m?
Yeah, so that's 128 meters. When
the time is 1.25.
Yes, 1.25. So 1.25 seconds after it's thrown, that's when it reaches its maximum height, its highest point.
Yeah.
Let's take a look. 1.25, 6.35, and they wrote it in this similar way. They wrote a fraction.
Yeah.
The ball is initially thrown from a height of 120. Okay. Any questions about that?
No.
So there's... let's just try part B.
Okay. So we put it to the calculator to find the roots first.
You don't need the roots, but okay.
Okay. We need the maximum, minimum.
Yes.
Okay. So the maximum of x is 10, and the max of y is 160.
Okay. And so, question B.
So would let me check. So would y be c? So it'd be 160 minus.
Mm-hmm.
Minus just. Wait, what would it just be a? Would a be?
Or what can you put in?
We can put in b, which is x.
And so, what number is it?
10. And then squared.
Yes, so that's x minus 10 squared. And a, I think, is just always a from the original one, because you always have to factorize it to make it equal to 1x squared.
Yeah.
So what number would that is a?
100. It'd be 10.
It's from the original equation. A is always a. So what would you have to factorize out to make it 1x squared?
1.
So this equation here.
Yeah.
What would you have to factorize out so that you have like 1x squared?
Minus 6.25.
Yeah, 6.25. That's it. Let's see. 160 minus 6.25 x minus 10 squared. That's the one thing I wanted to check on there. Let me just quickly see if it can make sense of something. Okay, let's just try question B.
Okay. So you need to find out the maximums, right?
Mm-hmm.
So it'd be minus 0.01, 0.975, and plus 16. So maximum of x is 48.75, and the maximum of y is 39.77 to 2 decimal places.
Okay.
So a would be 39.77.
Yeah.
And then minus 0.01.
Yeah.
open brackets x minus 48.75 close brackets squared.
Well done. And I just wonder if they put it as 39.77 or if they kept it as a fraction. Well, I don't have the answer, but you got it.
Yeah.
We got it. That's great. That's what I wanted.
Yeah.
There is let me see. Nah, I think we'd have to just finish it next time. But this is so you can see how. So what's the point of maths? This is applying it to the real world. So here's a bridge. This cable, it's a lot like a quadratic curve.
Yeah.
And because of that, you can find its minimum. You can find its roots. Like you can find different things.
Yeah.
And but the real world is much trickier than pure maths.
Yeah.
But overall, we got all those exam questions. I'm happy. So what would you give yourself for modeling with quadratics?
A half.
Yeah, that's why it's the last section in the thing. And every chapter, the last section is modeling, I think.
Yeah, it's really difficult. It's probably the most difficult one.
Yeah. Yeah, how was that for you, Adam?
That was fine.
Okay, so I think we'll be doing chapter 3 next time. How does that sound?
Yeah, that sounds great.
Okay. Any questions for me in general?
Nope.
All right, well done, Adam. You did great. And
thank you.
Have a nice weekend. I'll talk to you next time.
You too. I'll see you. Bye.
Thank you. Goodbye.